Hi. In this video, I'll be explaining from my understanding what topological sorting using depth first search with a stack implementation is. So you might be wondering, what is topological sorting? So this is an algorithm used to order the nodes from a directed acyclic graph such that for every directed edge from node B to D, B comes before node D in that order, basically. And now, I think to better understand this, we can come up with a real world scenario using topological sorting. So imagine you're scheduling tasks, right? And task A must be done before task B. Task B must be done before task C. And you can't do them in any order. There's a dependency between tasks. And topological sorting helps you figure out the correct sequence in such cases. And now let me explain why we're using depth first search for topological sorting. So for depth first search, we start on a unvisited node and explore all its neighbors until we reach the end, right? And once all the neighbors are processed, we add that neighbor, the last node that doesn't have neighbors, into a stack. And then we go backwards and check if it has other neighbors until we visit all the nodes of this graph. And by the end, the stack gives us the topological order when it's reversed, or basically when we pop the top item in that stack. And now let me demonstrate what I mean by using depth first search to find topological order, right? So let's say we start at node B. So we're using depth first search. We ask ourselves first, does node B have any other neighbors? Yes, it has neighbor A, neighbor D, and neighbor C, which is indicated by these arrows. And so let's say we go to neighbor C. So, and then we use depth first search again. Does this have neighbors? Yes. F. Does this have neighbors? H. Does this have neighbors? Yes, J. And we just keep using depth first search all the way until we get to the end. In this case, does K have any neighbors? No. And that's where at the end of the node, at the end of the depth first search, we add this node into our stack, right? And we mark it as visited. That way we don't revisit the same exact node. And now we start heading backwards. J, does this have any other neighbors? That's what depth first search does. It checks for all the neighbors of that single node. Does J have neighbors? Any other neighbors? No. So in this case, we just put it to the stack, mark it as visited, and head back. Does H have any other neighbors? No. We add it to the stack, mark it as visited. Does F have any other neighbors? Yes. Does I have any other neighbors? Yes, but it's been already checked as visited. So we don't add it to the stack. We head back. Does I have any other neighbors? No. It's the only one. And we mark that as visited and add this to the stack. Does F have any other neighbors? No. That's it. And we add it to the stack. Mark it as visited. Does C have neighbors? Any other neighbors? No. Visited. Add to the stack. Okay. Now we're back here. Does B have any other neighbors that isn't C? Yes. So we can start it off at D. Does D have neighbors? Yes. Which is G? Does G have neighbors? No. Mark it as visited, and we add it to the stack. Now we head back. Does D have any other neighbors? No. Add it to the stack. Does B have any other neighbors? Yes. It's A. Does A have neighbors? Yes. One of them is D, but it's already been visited. Does it have any other neighbors? Yes. We have E. Does E have neighbors? Yes. It's G, but it's already been visited, and it's the only neighbor it has. So we marked it as visited, add it to the stack, and now we're back here to A. Does A have any other neighbors? No. Visited, added to the stack. Does B have any other neighbors that has been unvisited? Nope. All the neighbors have been visited, and it's the only one that hasn't been added. So it gets added to the top. And now at the end, after we visit all the neighbors in this graph, we end up popping this the stack to get the topological order. So it'll pop B, then A, then E, D, G, C, F, I, H, J, and K. And this right here is the topological order from this graph. You might get different results, right? Because visiting neighbors could be sometimes random. We can visit neighbor D instead of visiting neighbor C, and it'll end up being it'll being a whole different topological order. But overall, that is a topological order.